Hi, this is Mrs. Wiederholt, and welcome to my lesson video on applications of rational equations. In this lesson video, we are going to look at 3 problems, and we will learn how to identify the variables, set up the equations, and then solve them. Now let's get started. If you are one of my Algebra 2 students, we are going to be looking at numbers 1, 3, and 5 in your packet, and then in class you will do numbers 2, 4, and 6. Okay, let's look at number 1. Chase can paint a room by himself in 3 hours. It takes Nick 4 hours to paint the same room by himself. If Chase and Nick work together, how long will it take to paint the room? The first thing we need to do is identify the variable. And in this case, if we look at the last sentence, it says if Chase and Nick work together, how long will it take them to paint the room? So we are looking for an amount of time. So why don't we go ahead and label this T for time. Now if you notice, there's actually 2 different types of times here. They give us the time that it takes Chase to paint a room. And then they give us another time that it takes Nick to paint a room. Those are individual times. It takes Chase 3 hours and it takes Nick 4 hours. What we're looking for is this collective time. How much time will it take both of them to paint this one room? Now how you will set this up, we will look at Chase's rate first. We're going to take that collective time and divide it by how long it takes Chase to paint the room, his individual time. We will do the same for Nick. We will take that collective time that we don't know yet, that's our variable, and we will divide it by the number of hours it takes Chase to do that same job. By setting each of their rates up this way, once we find that collective time, we will know the portion of the job that Chase did, and then we will also know the portion of the job that Nick did. In order to set up the equation to solve this problem, we need to understand that we need to combine or add the 2 rates. And together, those 2 rates will equal one job. So here we go. We will take Chase's rate, T over 3, and we will add it to Nick's rate, T over 4, and together it will equal one job. Now you are ready to solve this rational equation using the steps we learned in the previous lesson video. So I want you to pause the video, try to solve it on your own, and then restart the video and see if you got it correct. Okay, how did you do? The answer is 1 hour and 43 minutes. That's how long it takes both of them together to complete the job. Now let's look, and I'll go over it with you. So I look at my equation right here, and the first thing I notice is I have to find a common denominator, which is going to be 12. So I take the first fraction, and I look at the denominator, and I see it's missing the 4. 3 times 4 would equal 12. So I also multiply the numerator by 4. Then I take the second fraction, and I notice that the denominator needs to be multiplied by 3 in order to equal 12, and so I also multiply the numerator by 3. Now I look over on the right side of my equation, and the whole number 1 can be written as a fraction, 1 over 1, 1 divided by 1, and so this denominator needs to be multiplied by 12. Therefore, I also multiply the numerator by 12. Now remember, when we are solving solving rational equations, once we have the common denominator and have multiplied the numerators by what it needs to be multiplied by, we can just we can just cancel out that denominator, and now we will only use the numerators to solve for t. Now, once I have solved for t, I see that it equals 12 over 7, 12 divided by 7, which is the same as 1.71. Now we have to remember, what is our unit of measure? And our unit of measure is hours. So when we're talking hours, we don't normally say it takes someone 1.71 hours to complete a job. we need to take that 0.71 and find out what part of an hour is it. 0.71 is what portion of an hour. So if you look over here to the right, that's what I did. I took the 0.71 and I set it equal to x over 60. How many minutes out of 60 minutes is 0.71? And you multiply each side by 60 and you get x equals 43. So 0.71 of an hour is the same as 43 minutes. And that's how I got the answer 1 hour and 43 minutes. One last thing I want to point out is that if we go back here and we plug in 1.71 and we divide it by 3, we will find out what portion of that job Chase did. And the same here. If we substitute 1.71 for this t, we will find out what portion of the job that Nick did. Now let's look at another problem. Number 3. In a small rowboat going a constant speed, Monica takes the same amount of time to go 4 miles up the stream, meaning against the current, as it did to go 7 miles downstream, with the current. If rate of the current is 3 miles per hour, what is Monica's rowing rate, or her speed? Now, before identifying the variable, it might help if you really try to picture this problem. When someone goes up the stream and they're going against the current, doesn't that mean they will be traveling or moving through the water at a slower speed than someone who's going downstream with the current? The current, if you're going with the current, that pushes you, propels you along. So I really would look at that and try to make sure I can kind of picture that in my mind, and then that will help a little bit with the rest of this problem. Okay, so let's identify the variable. Well, if we look at the last sentence or the last question, it says, what is Monica's rowing rate or speed? And why don't we just label it X? Now that we have identified our variable, let's look at this question right here. What is her speed against the current? Well, we know she has a certain speed, and that's X. We don't know what that is yet. Now, they've told us in the word problem that the current is 3 miles per hour. So if Monica is going against the current, that means her speed is going to be slowed down by 3 miles per hour. So whatever her speed would be going against the current, it's going to be 3 miles per hour less than that. Therefore, we get x minus 3. So now, what do you think her speed would be with the current? Well, we take this rowing rate or speed of x, and now that she's going with the current, it's pushing her forward even faster, so now she can add that 3 miles per hour to whatever her speed or rowing rate is. So it would be x plus 3. Now we're ready to set up the equation. Now there's one formula that it might be good for you to know, and that is distance divided by speed equals the time. So what is the distance Monica traveled upstream? Well, she traveled 4 miles upstream. Now, what is her speed going upstream? Well, it's x minus 3. So we're going to divide that by x minus 3. Now, let's go over and look at how long it took her, at the distance she went downstream. Well, her distance downstream is 7 miles, and the speed to do that is x plus 3. Now, why do you think I'm setting those equal to each other instead of, say, adding them together? Well, let's look back at the word problem. On the first row, first line, it says, Monica takes the same amount of time to go 4 miles upstream as she does to go 7 miles downstream. So that means our time, each of these is time, the times equal each other. So I can therefore set these fractions equal to each other. Now you are ready to solve this rational equation. So pause the video and try to solve it yourself first. Then push replay or restart and see if you got it correct. Okay? Good luck. Well, how did you do? Well, the first thing you should have done is found a common denominator of x minus 3 times x plus 3. Then multiply each fraction by what the denominator is missing. And then after you do that, remember, we just cross out the denominators and we simply work with the numerators. You will distribute 4 to each term inside the parentheses, distribute the 7 to both terms inside the parentheses, and then you just start to simplify. Combining like terms, moving x's to one side, the numbers to the other side. And the answer you should get is x equals 11 miles per hour. That's her rowing rate. Okay, let's try the third problem. Number 5. Now, as I read this, try to picture it in your head, okay? Gracie and Rhett went on a bicycle ride. They rode at the same speed, but Gracie cycled for 15 minutes longer than Rhett. If Rhett cycled 5 miles and Gracie cycled 10 miles, find the number of minutes Rhett rode his bicycle. So, can you picture it? Rhett and Gracie start out together riding side by side. They're going at the same speed, but at 5 miles, Rhett stops riding his bicycle, and Gracie keeps going for another 5 miles because she went 10 miles. We have to find the number of minutes that Rhett rode his bicycle. So that's going to be our x, okay? That's our variable, the number of minutes that Rhett rode his bicycle. Now for this problem, it would really help if you knew the formula for speed. Okay, speed is equal to the distance divided by time. Okay? So to make things easier, why don't we use t to represent that time? And now let's write the equation that represents Gracie's speed. Okay, her speed is equal to her distance, which is 10, over her time. Now, all we know is that her time is 15 minutes longer than Rhett's time. Now we're ready to write the equation for Rhett's speed. So his speed is equal to his distance, which is 5 miles over his time, or divided by his time. Now you might be looking at this and say, how can we solve equations that have two variables, okay? But let's look back at this word problem. And on the first line, you will see where it says they rode at the same speed. That means we can set these two equations equal to each other because the speed of this problem equals the speed of this problem. So we're just going to set 10 over t plus 15 equal to 5 over t. And now you are ready to solve this rational equation just like we did in problem number 3. So again, pause the video, try to do it on your own, and then check your work against mine. Okay, hopefully you were able to find your common denominator, which would be t times t plus 15, and then multiply each fraction by what that denominator is missing. And remember, then we can cross out the denominators and simply work with the numerators. I moved 5t to the left side, and then I divided each side by 5, and I got t equals 15 minutes. Now I hope this lesson video has helped you to identify variables, set up equations, and then solve those equations on these application problems. So I look forward to working with you again. Have a good day. Bye-bye.